Okay, today we're going to look at sketching the inverse function given the curve of the original function. Now I will do a summary at the end, but here what we have here is we have a function, doesn't matter what it is, there's a function, and we need to draw the inverse from this drawing. Now in order to draw an inverse, you have to make sure that the scale on the x-axis and the scale on the y-axis is identical. So you can see here that 5 small squares is equal to 1, and 5 small squares on the y-axis is also equal to 1. The first step in the process is to draw the line y equals x, which is going to be a diagonal line. And because we've chosen the scales to be the same, it's going to be a diagonal line, slope of 1, and therefore is going to go through the corners absolutely perfectly. It's going to be at a 45-degree angle to the x-axis. Now, once we've actually drawn the y equals x line, that becomes the mirror line for the transformation. And what we're going to do now is we're going to draw a series of transformation lines, because this becomes a mirror line. We're going to, in order to get the inverse, we're going to reflect the curve in the y equals x mirror line. Now, when you reflect a curve, what you're really doing is you're reflecting points on the curve. And when you reflect points on the curve, you have to remember for a reflection that the line of transformation must be perpendicular to the mirror line. So for axial symmetry, the line of transformation has to be perpendicular to the mirror line. So, and also the other point, the reflection point, has to be the same distance on this side of the mirror as the original point was on the other side of the mirror line, the point on the curve. And it also means that when we get to this point here, where the curve touches the mirror, then there's no transformation. The point, well, there is a transformation. The point stays put on the mirror line. But when it comes to the other side, then we are doing the same thing again. We're marking a point here. We're going to be drawing a line perpendicular to the mirror line. We're then going to be measuring the distance along this line, and then measuring the distance, the same distance the other side, and actually marking a point. So, that is what the process actually is. So, we keep moving this along the mirror line until we get to a point where we can mark a point. Now, what we're going to do to help you visualize this process, I'm going to pretend that I've already drawn the red transformation lines. So what I'm going to put in now is all the red transformation lines. So what you see here is, this is what you do. There's your dot. You put a little dot on the curve. You draw the perpendicular to the mirror line. You then measure this distance, and then you measure this distance on the other side, and you mark a point. And then you move it a short way up the curve. You draw another perpendicular line to the mirror. You then measure the distance from the mirror line to your original point, and then the transform point, the axial symmetry point, the mirror point, is going to be drawn the same distance on the other side of the mirror line. And you keep doing this process until you've got a sufficient number of dots so that you can accurately draw the inverse function. So we keep going along, and here we go again. There's the distance. We measure the distance on the other side. There's, we draw another line, we measure the distance to the mirror line, we measure the distance beyond the mirror line, and mark the point. When we get to this point here, well, because the graph crosses the mirror line, then can you imagine actually putting your nose up to a mirror? You're touching the mirror, and the reflection is also touching the mirror line. So that point is actually on the mirror line. And then this point we've already done, but here you measure the distance to the mirror line, then you measure the distance on and mark it. And likewise here, you draw this perpendicular line to the mirror line. You then take your ruler out, or do it by eye. I mean, you can actually see here that it's the diagonal of the large square. So therefore, you go across the other side, and it must be the diagonal, the point must be up there. And you can do that for most part on a lot of points. So when you've done that, when you've actually drawn all the reflection dots, then you're now in a position to actually draw the inverse function. So what we do now is you draw the inverse function. Now don't forget that has to go through the mirror line here because the original graph was going through the mirror line. So there should have been a dot here as well. Now, let's just write down a quick summary of the process. So what was the first thing we did? We made sure that the X and Y axis have the same scale. So number one, you must make sure that there is the same scale on the X and Y axis. Number two, draw the line y equals x. And because the scales on the X and Y axis are identical, this line will always be diagonal i.e. at 45 degrees. Number three, draw red lines which are at right angles to the mirror line. Number four, distance to mirror line from graph equals distance to plotted dot. When you have sufficient number of plotted dots, then you can join the purple dots up in order to get the reflection, the black reflection line. So basically, that's all you have to do. I mean, please, by all means, look over the video again and study it and make sure that you are getting it right. Okay then, good luck. It's relatively easy, very rarely comes up, unfortunately, because if it does come up, it's a nice, easy, pleasant question to undertake. Once again, thank you for watching.